guys, welcome once more to class online. My name is Mr. Dami, and in this edition we shall be looking at Jamb Physics 2010 question number 11 to number 15, and we shall be destroying those questions and we shall be making it simple in a way that you can understand. Now don't forget, if you learn something from this video, click on the like button. We have a lot to share with you that will better help you understand physics. Let's get to the question now. Question says, number 11 says, if a wire 30 centimeter long is extended to 30.5 centimeter by a force of 300 Newton, find the strain energy of the wire. Now, you know, strain is under elasticity. In elasticity, we have stress over strain as Young modulus. So the elasticity constant is Young modulus, and it is stress over strain, right? Because they find the strain energy. The question did not say find strain. The question they find the strain energy. That means it is also the elastic energy, and that is simply, what is the energy for elastic material? E equals 1 over 2 Ke squared, or 1 over 2 Fe. So anything elasticity, when they mention to find energy, the energy of an elastic material is half K squared, where K is the elastic constant and F is the force and E is the extension, and that either of this formula will work. But in this case, we have force, so that I'll be using this formula. So I'll be saying E equals 1 over 2 Fe, right? Now, but if it were an elastic constant given, you use K. Okay, now 1 over 2 is 1 over 2. Force in the question is 300. The force will be 300. While the extension is the distance between the two lengths, 30.5 minus 30 centimeter, and that will become 30.5 minus 30. But remember, they are in centimeter. Extension is the subtraction of the two lengths, right? That's the extension. But they are in centimeter again. They must be in meter. So to change the meter, divide by 100 or times 10 to the power minus 2, which is still dividing by 100. Okay, and that will give you this. So that will give me 300. 1 over 2, 300. Then 30.5 minus 30 was 0.5 times 10 to the minus 2, and that's it here. So I will multiply 300 times 0.5 divided by 375 times 10 to the minus 2. And that can also be, you can move this point, this minus 2 backward, 1, 2, and 3. The answer, sorry, only 1, 2. You move backward twice, 1 and 2, 0.75 joule. And that is the elastic energy or the strain energy. Remember, everything energy in elasticity has to do with 1 over 2 K squared or 1 over 2 Fe, right? And that is the answer. Number 12, no, so the answer for number 11 is D. Number 12 is in hydraulic press, the pump siphon piston exerts a pressure of 100 Pascal on the liquid. What force is exerted if the second piston of cross-sectional area 3 is of cross-sectional area 3 meters squared. Now here you have what? Pressure 100 Pascal, and you have what? Area meter squared. Can you remember the pressure formula? Now the pressure formula says what? Force over area, right? For any time, for any pressure question, pressure is always force divided by area, and in this case the pressure is force over area. So I'm to find the what force, that is find the force. So I will cross multiply, and that will give me force equals pressure times area, and that will give me my pressure is 100 Pascal and the area is 3, and that will give me 300 Newton. And that is the answer. D is the don't forget that pressure is always force over area, and you are trying to find the force. So cross multiply, get your force as pressure times area, and put in your value and get your answer. And that was just what I just finished doing. And then let's go to number 13. Number 13 says the accurate measurement of the relative density of a liquid of a substance in its powered form is done with a beam balance and what? Now, if you want to measure relative density, there are two things that are majorly needed. Do you know what they are? One of them is the beam balance for measuring the mass. Okay, you know that relative density is mass over volume, right? So, but to find the relative density, you need two things. One of them is the beam balance. For the second one is what? Is it an Eureka can, a burette, a pipette, or a density bottle? Do you have any idea? That is actually easy, right? You will need a beam balance and a density bottle. These are beam balance. You need to weigh the masses, okay, on the beam balance. These are beam balances. These are actually scales, sorry, but they are functioning as the beam balance of this question. Then these are density bottles. So you need two things to find relative density. You need density bottle and you need a beam balance. Remember that relative density is the density of a substance in relation to the density of water. So therefore, you will need a density bottle to find the density of the material and the water. Then you will need a beam balance to weigh the material and the water, and that is what we will need. So the answer is just a density bottle, a density bottle. And number 14 says a hydrometer is an instrument used in measuring what? Is it density of liquid, relative density of a liquid, relative humidity of liquid, blood pressure of liquid? Do you have any idea? This, now actually when you hear the word hydro, it should remind you of D. The word D should remind you of D for density. Yes, it is density. Now, if it is hygrometer, if it is an hygrometer, hygro is used to measure relative humidity, but hydrometer is used to measure density. Now, in my mind, I just coded it with the word D. The word D is D for hydro and D for density, right? Why G for hydro and then relative density? It will be used to find relative density. So the answer for this question for hydrometer is actually density of liquid, and that is the answer. Hydrometer is used to measure density of liquid. Like you can see it here, this is an hydrometer. When you place the hydrometer in this test tube, you wait until it stands straight. So when it stands straight, then you cannot take reading to measure the density. It will need to stand straight on its own in the water, and then you cannot take your reading, okay, this way. And that is the hydrometer. Now number 15, the last one says one special advantage of alcohol over mercury as a thermometer liquid, that should have been a thermometric liquid, is its what? Now alcohol has one advantage, and one of the advantages of alcohol, like we have it here, is that it is cheaper than mercury. Number 2, it can measure very low temperature. It can measure a low temperature because its freezing point is low. It can measure negative temperature, like if you have minus 40. It can measure up to minus, but mercury can measure very, very low temperature. That means icing temperature. Alcohol can measure because alcohol does not easily freeze. So alcohol can measure very low or cold temperature, and that is, but mercury can't do that. It can measure the temperature precisely because it has large expansion coefficient. The expansion is regular. So the advantage of mercury of alcohol is that it has low freezing point. It does not freeze easily. So that means it can measure very cold things. Like if you are in the part of the world called Antarctica, it's always cold. You can't use mercury thermometer there because it will not be able to take readings. You need an alcohol in glass thermometer because alcohol can handle cold substances and can measure their temperature. But mercury has not a very low freezing point, so it can measure very low temperature, and that is the answer. So alcohol only is the material that can help measure very low temperature, and therefore the answer is simply option A. It has low freezing point, making it to be able to measure extremely low temperature, and that is the answer. And that brings us to the end. Of this session. Don't forget, if you learn something from this series, I want to get more content from us, click on like button. We have a lot to send to you that will help you. Until you see you guys, take care of yourself and bye for now.